title of this is Scaling Humans and Code with AI. And I'm going to cover a generative AI dev workflow, but more principle driven. So some of you are more technical, some of you are less technical. Hopefully there's something here for everybody. So a little bit about me. I've been building software for about 20 years. I went through YC as a solo founder in 2017. I worked on some projects, as Alec mentioned, Netflix, Disney, and lately I've been building AI engines. Multiple, in fact. So I built a total of 3 at this point, working on the 3rd. And they collectively had hundreds of thousands of conversations, tens of thousands of appointments scheduled in the dental medical space. And I've done a lot of this myself. And so this is me ranging between small teams and heavy lifting myself. So some of these lessons in the trenches, I hope, are useful for people. One thing to keep in mind is this is a snapshot. This isn't like how you should do generative AI. This is things I've found useful. So your mileage may vary, and we don't know how this is going to change in the next few months, but we know it's definitely going to change. So to recap a few milestones, as you may have heard, the new model from OpenAI became the 175th best competitive programmer in the world. So that's impressive. LLMsys.org, which is where I follow kind of these model leaderboards, continues to have models outperforming each other. Google's making a strong showing now.
And you said LLMsys?
Yeah, LLMsys.
That's what I guess.
Yeah. It's this open competitive chat arena where people evaluate model performance. So that's continuing to shuffle. New AGI benchmarks are being approached, and new benchmarks are being created because the old benchmarks are too easy now. This one is a multi-language software engineering benchmark. And of course, as many of us know, there's all of these tools we can use now to generate our code for us, and they claim to generate software from scratch without doing anything. So I'm going to cover that and these other things, but overall, I'm asking this question, and probably many of you are too, how do we ride this wave and not get drowned by it? So the best kind of way that I thought about this is to take a step back and think about mental models, right? There's a lot of specifics, a lot of tools, a lot of chaos, but there's some things that hopefully won't change, or at least they won't change too soon, or they're not likely to change. And that's most of this presentation are on these principles that won't change. Specifics, though, that I will mention in this presentation that I use to demonstrate these tools, and these are in fact my go-to in production that I typically rely on. Cursor is my IDE. Probably needs no introduction here. It's a very AI-centric development environment. Aider.chat is a very lightweight command line wrapper around foundation models. It's just the perfect level of abstraction I've found. So I try a lot of tools and I kind of land back on Aider. It's scriptable, it's text-based, and you'll see screenshots of that here. And then the models here that I'm sure you're familiar with.
And Riley, you might get into it, but so Aider, you said, is the command line thing versus Cursor, which is like a GitHub kind of thing. Do the two work well together?
They work very well together. Yes, in fact, so Cursor does a lot of what Aider does, and Aider does some of what Cursor does. And so these tools have their own strengths and weaknesses, and I've found to play some strengths in some, and then switch off to others. And some of it's just ergonomics. Like, what do you feel comfortable with? What do you like?
I'm so excited about the talk. This is exactly what I need.
Oh, it's so good to hear. Awesome. Thank you. It's great to hear. Okay, so taking a step back to mental models. So things that hopefully aren't going to change, at least too fast. 2 broad categories from that big messy chart, the big messy slide I had. We have language models, we have orchestration tools, and maybe this includes the broader ecosystem as well around these models. The general trend is that the language models are becoming smarter and smarter, right? They're more like a smart human. The orchestration tools are increasingly agentic and integrated. So they're being given more independence. They can fix their own bugs, write their own code, and they can integrate with every software tool, increasingly every software tool a human can use. So this is the trend. We're not there yet in either category, but this seems to be where things are going, and I think we can predict that trend to continue. So that's the wave, and so as startup founders, engineers, investors, how do we ride this like massive shift in this underlying technology? So here's what we're going to cover. 5 mental models in the next, hopefully, 8 to 10 minutes or so. They're roughly ordered in chronological sequence of as you go through a project to build something, with the exception of the first one, which is, I think, the most important, and you'll hear echoed throughout the rest of these concepts. So agency is a concept you hear a lot in this AI ethics world. It's the ability to act independently. So we know that, so from a human standpoint, we have this idea of agency. And then we, of course, have AI agents, who we all know and love, these independent acting software units. So the question is, how much of this are you giving away as you go through your dev workflow? And this isn't an absolute. It's not like you have AI do everything or not. But there's a risk as you generate code, as you start to rely on generated code, you cease understanding it, or your understanding of it grows less. And that's a liability because you can't fix something you don't understand. And so this concept of human agency, and it turns out has a lot to do with human knowledge. But agency is not the only thing that relies on knowledge. If you think about it, the ability to innovate. If you know how something works, you can come up with new ideas. Your initiative, you might get excited about something because you know about it. Your ability to take responsibility, like as a technical leader of your organization, if you are a CTO, your ability to be responsible for every line of code running in production depends on your knowing that code. Collaboration with your team, hiring, recruiting, these are all dependent upon understanding. So it turns out you need these to run your startup or to start a company, which means you need this. So this quote down here, I don't know if any of you have heard this before. 80 people can write code that a computer can understand. Good programmers write code that humans can understand. Martin Fowler, this was my go-to for years and years. Totally awesome, very wise. We now have a third actor in the mix, which is a language model. So your code that's written is no longer for an audience of 2, it's for an audience of 3. The computer runs it, the human understands it, the language model both understands it and can write it. So this, of course, by the way, the language model understands it. This is a point we'll come back to. So what can happen is you generate more and more code, is this language model can drift up and to the right. So this, the code there is actually a mailbox code, working code, and it says hello world. And it works, right? So a language model can understand that and could write it, but you definitely couldn't as a human. So this drifting to the right is a loss of agency for your ability to intervene. So fortunately, these language models are very promptable, so we can optimize this language model and prompt it to optimize for agency. So here's a nice clean Python, right? You can read that. And so this is a very steerable, very promptable contributor to your code base. But it's important to remember that you're in control of how much agency you'd like to delegate and how much you would like to keep. So the goal and the purpose of this talk and the title of this talk is around using AI to scale both knowledge and code. And you can actually generate code, which is the subject of this next principle, which is generating knowledge. So we can generate code. Turns out you can also generate knowledge. So very quick, granular example. This is Cursor. I highlight a line, Command K, and then Option Enter, explain. It's a great way to have just quick questions, right? Like get go-to all the time. And it's just great because you can learn more and more about your code, just about your language or anything. Another way to kind of understand your code more is to have it refactor your code, make it more expressive, make it express what it does. And this is, of course, a principle of this well-designed code in general. Your code should clearly be visible in terms of what it does and how it functions. Comments. So liabilities and comments in the past where they're just another line you have to maintain and they just clutter up your code base. Like, that still might be true, but the great thing is language models can maintain their own comments. So when you change the code, they change the comments. So this is really handy. Just explain how all the stuff works, and it just puts the comments in. And sometimes I commit them because it's really great to have all that data in the code base. Other areas of knowledge, these are more obvious, but classic requirements documentation, technical docs, developer, like all of this stuff can be generated. Really good case for reasoning models, by the way. So if you're generating like a user story or a specifications doc, having a reasoning model think through its whole process to generate those docs can produce some incredible results. And by the way, I've had some amazing breakthroughs just turning on voice mode and just having a conversation with O1. So anyway, incredible. But so here's an example of doing that through but there's something else, maybe less obvious, about generating knowledge. When you create docs, oh, and by the way, this is the first introduction of Aider. those of you who are used to the command line, this might look very familiar. Those of you who are not, I'm sorry for all the code and everything on the screen. But the idea here is that these files we have explicitly loaded into context. It gives you very specific control over that context window. And then you give it a prompt. And so in this case, I loaded 3 files into context and I asked it to write a documentation file. And incredibly, that works, like really well. And the thing that might not be obvious is after it generates that file, you could load that documentation file later into context, which means that your docs become prompts. So as you generate docs, you generate input for your next iteration of the code. So your language model is understanding your code base more and more. For that matter, your requirement docs, your specifications, all of those things can become prompts. So there's this kind of self-generating cyclical pattern here that's really powerful. So really, instead of just generating knowledge, we're generating knowledge, which is the human side. We're also generating prompts, which is your language model side. The prediction, by the way, that in the future our libraries will come with librarians. I think that's a cool feature. You could ask how something should be done. Supabase has started to publish prompts for some of their client tools, which is pretty awesome. Okay, so this section's on prototyping. I'm going to go fast through this. Plan to throw the first one away. You will anyway. One of the AI engines I built, I consider a prototype. It took about 3 weeks, and this thing has had tens of thousands of conversations, and it's doing great, but I consider it a prototype. And it's wild how fast I was able to make it using these tools, and then how much I learned from doing that. I'm not going to spend too much time on this, as I mentioned, because it's just such a greenfield just area. And all of these tools, you're giving away a tremendous amount of agency. You're saying, build this for me from scratch, I don't care how you do it. And sometimes that's a great thing to do. But if you have to control and be responsible for a piece of tech in production, and you're organizing a team around that, you have to think carefully about that agency. Choosing a stack. So this is where to answer your question, a production stack is something that top is it works, prototyping the bottom. Many of us know it's far more involved to maintain something in production. So, oh sorry, if you want to take a picture of that. So choosing the stack of what you rely on in production when you're using a language model, there's a few things I found really helpful. We need to have deterministic scaffolding. Sorry for the non-technical people in the audience, but basically, language models generate stuff. You don't know what they're going to do. They do something different sometimes every time. So you need to have a fixed container for this stuff. This is a layer of the squiggly line, lets us type check that. There's testing, of course. A few stack considerations when you're selecting a stack. I think about this area of knowledge in terms of vector space. So like here's a visualization of kind of a reduced simplification of how language models store their knowledge. And I think of picking a tool that's in crowded space so the language model already knows about it. Keep in mind vendor docs are prompts. I scraped one of our next presenters here and his docs here into context, which is perfect, by the way, for the docs going into as a prompt. And then I can use his docs to generate something that I want to have. So pick a vendor with docs that can be scraped as prompts.
Can you summarize what would happen there versus Harry Potter versus Luke Skywalker? What's the result?
We should try it. I will do it maybe while Sam's presenting, and then maybe we'll see what happens.
Okay, but just what's the intent?
We would just replace the names in this case. It's just switch the names. This is a low ball. This is easy. The language model will be able to do this without a problem. Yeah. And then the other thing is exploit model bias. So these foundation models are built in with existing biases. So if you generate something with Claude, you'll see Tailwind and React. And so they're obviously training it on those tools. I did think I published a foundation starter that works for me with my basic stack. Here it's open source. I just published it. So if you're interested in looking for a stack, TypeScript, Supabase, Next, it's got testing and debugging built in. Feel free. Just leave it as get a star if you like it.
We've got the slides will be shared. So if the QR code is small and you're struggling with time, don't worry about getting to shared.
Cool. And then the very last point, which I'll go through quickly, is curating context. So this is more of what we have been talking about, it really thoughtfully putting things into context. The smartest human can't get something done if they don't have the context. So think about this carefully. You can curate by removing context, taking things out of the model's memory, trying a task again. You can clear chat history. This applies to any AI dev tool you're using. You can remove stuff. And then you can add context, right? You can scrape in docs. You could put in a debugger and take a screenshot of a stack trace. And then Aider has a feature you can paste in your screenshot, which is awesome. So that just gives runtime information so that your language model can debug what's actually happening. So In closing, these are the kind of mental models that hopefully won't change too fast. They've helped me navigate a lot of things. Hopefully they help you too. And as I mentioned, there's this flywheel that happens as you store the knowledge that you gain in your docs. Not only humans, but also language models increase their understanding, which increases the ability for you to execute on the product. So thank you very much. I hope there was something useful in there for you, and I'll turn it over to the next.